Hi all. In this video, we are going to see about a paper titled Diffusion Models Beat GANs on Image Synthesis. So this paper is about comparing two generative models. One is a likelihood-based model called diffusion models. Another is famous current state-of-the-art method during the time of 21 GANs model, which GANs has certain advantages. How that advantages has been overcome by these newly developed diffusion models. So this paper is about a comparing between the two generative models. This paper assumes to have this overview of understanding that people has some basic fundamentals of what is generative models, what is GAN, what is likelihood based models, what is diffusion models to a certain extent. And also, people have to know or have some minimum understanding about how model can perform on image vision problems. What is the metric being used, like FID score. So let us see overall view of this paper. So this paper says that generative model recently during the time of 21 has generated have achieved uh, in generating a human-like performing a language. I'm not sure on what way they are saying the human-like, human-like producing images, music composition, etc. And still what they claim is there are still some broader room for improvement in those models for effective innovative music productions and developing 3D simulation environment for graphic designs and games. So for those two popular models are, one is GAN, which is the current state of the art, and according to the FID metric, this has a very great quality in producing generating sampling images. But unfortunately, their diversity, like they don't capture the true entire probability distribution. They capture only a narrow part of the distribution function of that particular data set. So, and another thing is it's very hard to train those models because it's very massive parameters, and identifying those hyperparameter and regularizing for an effective training is a bit difficult. So this two limitations, like capturing a very less diversity and also hard training, is not occurring in another set of models like likelihood based models. Likelihood-based models, as I said, it doesn't have this limit. Right? It can scale very well and it can cover a wide diversity. But unfortunately, the fidelity that it generates is not as far as similar to the GAN. And another one of the thing is it's a bit slower, like variation autoencoder is one of likelihood is slower than GAN. So in this paper, they are going to see about a class of likelihood based about diffusion models, which has been proven that it has a wide, great distributions covering that PDF, and compared to the GAN, and easy, so that it has an easy scalability. So how does it work? Is hierarchical models, removing the noise in a stepwise, but still it almost covers a very PDF, a wide coverage of the PDF, but it still lags in GAN in terms of producing a good quality images. And the author assumes that it could be for two reasons. One is for that GANs are using the current state of the art deep learning architectures, which diffusion models are not doing that. Another thing is GAN can very well make a trade-off, giving a limitation in diversity and improving the fidelity, which this model doesn't have that kind of trade-off. So this paper is aimed to make a novel architecture for improving the quality, and also making devising a novel a scheme for trading off the diversity for improving the fidelity in the diffusion-based models. So the paper is organized like how the background given in that section is not that great, but possibly we will make a separate video to understand about what is likelihood-based model for generating quality images. Like there are different models, and how that diffusion models are custom tailored for making a new architecture and new trading of that improving the quality, and they have shown some results in section 5. Hopefully, if have time in the future things, we will go through this paper, or else we will try to more focus upon what are the different likelihood based models and what are their limitations by going through different papers, especially this paper, denoising diffusion probabilistic models. And there is another improved version of this denoising diffusion models. And there are so many papers we could able to see with respect to this, like a deep variational autoencoder. And this is another paper, like gradient based data distribution for generative modeling, and it is very interesting. uh, this is also interesting, but this paper is a bit interesting one as from Peter Battaglia. There will be some injection of physics into the deep learning to make high quality generating machines. Always we are injecting in physics, it would be ending up in a good computational efficiency. They are trying to use DCT, discrete cosine transform based encoding those representations and how that's been done. So other papers also lies here, hierarchical autoregressive models and very deep variation autoencoder models. So hopefully, if we have time, we will go out through this paper. But maybe we'll try to take one or two papers from this listed one and try to see what they covers about likelihood based models, especially variation autoencoder models. Thank you.